So welcome to this university talk. I'm Brian.
Stéphane.
So we're going to talk about Spring Boot for the web tier this morning. We like to start often with a show of hands for talks. So who's using Spring Boot at the moment? Okay, quite a number.
Yeah, 50%.
Who's using Spring Framework? Just Framework? Right.
Okay.
Hopefully.
Okay.
And who's never been using Spring at all? And yeah, few.
Okay, 4.
Awesome.
5.
Good. So this is a university session, but it's mostly about live coding, so don't expect a lot of slides. And as for the agenda, we'll try to do 75 minutes and then a break of 20-30 minutes, and then the remaining time. So you'll have some time to get some coffee and get your
sugar in your brain.
Yeah. We didn't want to come up with a really demo application, just dumb application for this session. So we wanted to build something that we can use and that we want to use within the team. So we'll demonstrate many things during this session. And one thing we know right now is that for Spring Boot, you have a feature that's called externalized configuration, not confirmation.
Oh, confirmation.
Yeah. Externalized configuration, and that's where in Boot you're using you can define your own keys and values, but also predefine values for properties to define, I don't know, the HTTP server port you want to use, or logging levels, etc. So we're using this at the moment in Boot pretty extensively, and to provide this and also the feature you can see in the IDEs. So you get auto-completion in your IDE for those properties. For this, we have to do something with Boot.
Right. So the way it works is we generate metadata for every Spring Boot version, and that's what the IDE is reading to basically build a registry of keys. And the thing is, we want those metadata to be accurate. So the thing we do is we build a set of tools around those metadata to namely make sure that the documentation is consistent, making sure that any written metadata is still accurate. Also, make sure that we provide you guys a changelog for every Spring Boot version. So if you go on the wiki, you'll find for every release the keys that have been added, removed, deprecated, etc. So today what we're going to do is we're going to show you those tools. It's basically a command line tools, so that's really basics. And we're going to, because it's better to have a web interface for it, we're going to build a web application on top of it during the session.
Right. So.
Right.
Okay.
Okay, so enough for slides. That was the end of it, hopefully. So I just have here basically the library. So this is the service that we're going to use for the remaining of the session, which reads some metadata and generate a diff. And just to show you what it looks like, this is something that we actually use internally. Just to show you what it looks like, I can run that app, which is doing some stuff. So basically fetching jars from Maven Central, from a repository. So retrieving those jars, there's metadata into it, and then computing a diff. And as you can see, there is a very interesting diff between, in this case, milestone 1 and 3, I think.
Yeah.
Right, a bunch of stuff here. Right. So that's not very interesting because it's command line and maybe you want to do something better with it. So we're going to build a web app for that. If you wonder, at the end of the session, we will push that code on GitHub. So you can try it out yourself. You can see also that there are individual commits that basically shows exactly what we have changed for one particular demo that we want to do. So if you want to go back on that after the session, it's very easy. You just take a commit, and then you'll get exactly what we've changed.
And during the talk, don't hesitate to raise your hand or shout if you have a question or if you're kind of lost.
Yeah.
We will try to explain every step. We won't code everything, but most of it.
So yeah, please shout because we can't see you, actually, which is a bit weird. Okay, so we have here a new module with a basic application. So what we want to show you here is the kind of application you can build using Spring Boot default, so basically having no opinion about configuration at all. So just take the default, the kind of service you can get. So quickly, we have here a set of just a simple library, a simple service, sorry, that's calling the library, so this one, and basically generating a model for our view. This is the model that we're going to use.
And we want to render that model in a template view to have a nice HTML UI.
Which is here.
Here.
So yeah, this is Mustache. Mustache, right?
Yeah.
Yeah, okay. So this is the general layer, and there is this div table, which is actually the content we'll see in a minute. And it's calling this one, which is basically listing a bunch of properties. Right?
Yeah, that's Mustache templating. If you don't know the template engine, it's supported in Boot. That's one of the engines that we support in Boot for views.
There is one controller, which is quite, let's say, simple. It's actually taking this service, basically taking a from and to version, which are the two versions that you want to diff, calling the library to generate some diff. And once we have that, just putting some values into the model and returning diff here, which is the name of the view. So this will render that.
So if we're good, instead of having to generate that manually and create a wiki page for this, we can have a dynamic application which you can give two versions, and it will fetch the metadata within the Maven artifacts, and generate the diff and render a nice UI page to show all the differences between two versions of Boot, which keys have been added or removed.
There is also a package called static. So this is a jar file, by the way. This is not a WAR file. And in this one, we have our CSS and a favicon, which is named favicon.ico, and that's basically the default. So basically, Boot is going to check if that file exists, and if it exists, it will automatically configure your app to use that favicon. And if we look at the app itself, so for those who don't know about Spring Boot, this is a Spring Boot app, basically a class with that annotation and a simple main, which is basically run this for me. Okay, so let's try to do that. Run this for me. And it will do something.
Yeah. We haven't done anything, I mean, in the application properties, we haven't changed or even set something special. It's a very simple Boot application with the defaults. Okay. So that's what we wanted, right?
So we have here the summary of the groups, and for each groups, that's basically the same thing that we had on the command line. For each group, we have green if it's new, red if it has been removed.
So, for example, here the gzip one, or let's say, or that one, the auto configure exclude. That's one new property that's been added in the M3 milestone. And that's how you see which has been added or removed and which properties didn't change.
Right. So if we look at the dependencies now, because we haven't done that, so Spring Boot has the concept of starter, which is basically something that you add for a specific use case, and Boot will make sure to give you a minimal set of dependencies that allow you to implement that use case. So we have two of them for now. Web, which is implementing your web application, and we want to use Mustache. So we basically telling that we want to use Mustache as a templating engine. And because those are present on the class path, when you start the app, Spring Boot will basically look at your class path, will figure out, hey, okay, there is something to build a web application. There is also a servlet container on the class path, so you probably want to build some kind of web app. So I'm going to configure an embedded container for you. I'm going to configure Spring MVC with sensitive defaults. And I can see that also Mustache is present on the class path, so I'm going to create automatically a view resolver for Mustache, which is why when we return on the controller, we say, please render the diff view. It's going to find this diff.html. The reason why it does is this is also, again, default in Spring Boot. If you put your templates in a package called templates, Spring Boot will look at that by default. You can change that if you want. Same thing for the static. So if we go back here, you can see our favicon here, which is basically that stuff.
So that's the starting point of our presentation. And during the session, we'll show not only Spring Boot features, but also framework features and other things as well. And the end goal here is to show you what you can achieve and how you can do things with Boot when you're developing a web application. So we'll do many things.
Right.
And we definitely want to improve that application right now because it's very simple, but there are many things we can change. And
the thing also we want to show you is the developer experience that you get with Boot. So you have a simple setup, a simple app, and you're going to add more complex features. And what does it take to achieve that? How the tools can help you. The IDE and other defaults that would provide other features that we're going to show you. Yeah. But the most interesting features in Boot is the banner, right? So we're going to change it. And again, like everything in Boot, there is a default. So if you create a file called banner.txt at the root of the class path, and you put your banner in it, well, if you do that, then it changes the banner.
So yeah, starting Boot 1.3, you can put colors in your...
Which is awesome, right? Everybody, we're waiting for that. All right.
Now we're ready to...
Yes, yes, okay. So the first thing we want to show you is validation, quickly. Let's put some crap in here. Okay, so what happens is could not load Spring Boot foo. So actually our service is not checking that the input is consistent with the release. So we're calling the library, asking fetch on the repository version foo, which obviously does not exist. We get an exception, and that basically tells that the server did something wrong. Whereas actually it's our fault, we provided a wrong input.
Yeah, and it's displaying a white label error page, which is the default in Boot. And but you can change that. So the end goal here would be to have a better error status and something meaningful for the user.
Meaningful, right? And so the white label error page is ugly enough to force you to do something about it, right? So by default, we want to show you something, not just a plain stupid page, but something that's really meaningful. And basically, if you create a view which is named error, Boot is going to pick that instead. All right, so let's first make sure that we can validate those versions. So we're going to use GSR 303 for that.
Yeah.
So we need validation. So the first thing that we would do is basically add a dependency for that.
And many things with Boot are done with starters. So that you'll see that's usually the path you're taking when you want to add a new kind of feature into your application or a new feature space. Then you start with adding a starter, which brings in the dependencies, and also triggers some default configuration, and then you can start coding. So right now we've added the starter for this, and we can add the validation feature for our app.
So what we want to create is a custom GSR 303 annotation that basically states that the input string that we provide is a valid version. So we need to constrain that. Right. And it's a version validator, I guess. Yes, that does not exist. So let's create that. So constraint validator for version, which is our annotation, and the input is string.
Okay, so the goal here is to really validate that a given entry for a version exists, so we can match it with a pattern that we're using here. So 100 and maybe M3 or something like this, or RC1, and we need to verify that not only the given value is not null, but also that it's matching the pattern. So if it's matching, then the version is valid. Now. Right. We definitely want to use that in our application to validate the version we've been given by the user.
So what we have is those two strings needs to be validated now. And to be able to add constraint on that, we're going to generate some kind of DTO, simple DTO for it, which is those.
So that's a form object, I guess. That's the when the controller is receiving the request, instead of having many arguments in your controller, you can create a form object that will gather everything in it. It will be done automatically by Spring MVC. It makes the things easier a bit here, and also you'll see for validation, it's definitely helpful. So instead of getting bits by bits, we're mapping everything into that diff request where we've just created.
And also the advantage if you're doing that is if you have a higher value method that basically checking the state of the input, instead of coding that in the controller, which is this if, you can have a dedicated method for that, which I have. So this is basically the same thing, right? But it's contained within the object. So now I need to trigger validation. So how do you do that? Well, you are saying that it's valid, and you also need to tell Spring MVC that this object is actually the input of your form. Okay, so let's see if that works now. So again, no configuration of the validation whatsoever. You just code what you have to code. And if we do that now, well, we get 400. And we get a validation failed. So we get the proper HTTP status code, 400, and we also have a validation error, which is basically what we just implemented. Okay. Right.
So the next step would be to have...
before we do that, there is one more thing, right? If we do this,
all right,
it will work. Which is weird, right? You'll get an inverse diff. So we probably don't want that. So let's see. We have some checks here. So let's add a new one. So we have a version string comparator, which is making sure that the left version is previous to the right version, basically. And if it doesn't, we're going to throw an exception.
Okay, so now we're checking that the versions exist, that they look like versions, and also that they're in the right order. We don't want to have some kind of reverse diff that doesn't really, that isn't helpful, actually.
If we restart now and we try, it will fail, and it will fail with a 500, which is probably not what you want, since you're basically validating input, and you want to basically tell the client that something goes wrong with the input.
So we kind of need to catch that business exception and do something with it to really map it to the HTTP status we want. So for that, you can do it many ways, but the simplest way here is to add that response status annotation on the exception itself, and it will be mapped by MVC to have a 400 here as well. So different ways of doing things, and so here what you've seen is some things are really core to boot, others are just really regular Spring MVC. but you can see that it's all part of the same code path and
well integrated.
Same experience.
By the way, we didn't have to do anything for the first validation, so the constraint validation to generate a 400. So Boot is doing that by default. If one of your controller is basically throwing an exception that contains a validation error, there is a based exception in Spring that basically gathers that. It will figure that out for you and change the status code to 400. So you don't have to. In this case, in the case of our own exception, we had to map it, so there's plenty of ways to do it, and we just show one of the many ways.
Yeah.
So let's change that thing, right? It's a bit ugly.
That error page.
So like I said, there's many things you can do. You can create a error.html with some mustache templating, and then it will render that instead. You can also configure error pages for status code, and that's what we're going to do now. And the key thing for that demo is to remember you have access to the full embedded container that Boot auto-configures for you. So there's plenty of ways you can change it. So there is the properties you can use to tune SSL settings, security, port, and whatever. There is a customizer, that's what we're going to do now, that allows you to, through code, to change the builder that the container, that Spring Boot will use to create the container. Or you can even create your own factory, and in this case, you're basically in total control how you basically start the app.
So it's not because the container here is embedded. It's not because it's embedded that you have less control. I'd argue it's quite the opposite, because there are many ways to change its behavior and configure it, configure many things about it. So here we'll show one of the most flexible ways of doing this, which is implementing a customizer, a class that Spring Boot is recognizing.
Oh wow, what's that? Yeah. Okay, that's the one.
So we're creating a bean, and when the application starts up, Spring Boot will check for those and apply those to the actual embedded container you're using. So if it's Tomcat, it'll do the right thing for Tomcat. If it's Jetty or something else, it'll do the right thing as well. So it's quite independent actually from the choice of container you're doing. So here we are telling the customizer to add a new error page for a given status. We won't use the default white label one. We'll use our custom one, which is 400.html right here.
Okay, so let's restart again. Right. And if we try.
Nice. Okay. We get a guy. Yeah, good.
So this is our error page. Very useful, right? Okay.
All right.
That was it. I'm fed up of restarting the app. What about you?
Yeah, that's kind of boring to always restart. Our application it's quite small, but if it's getting bigger, then we'll have to wait again and again. And that's, I don't know about you, but I find that very painful, having that experience during development. Even when you're changing quite a small thing, you have to restart the application and for very, very small changes. Hopefully we can do something about it, because for Boot 1.3, there's a new feature that we really like.
Yeah, and it's called DevTools. Okay, so let's add that.
If you want to use DevTools, it's all about adding a dependency. So Spring Boot DevTools and having it in the optional scope.
Because this is really something that you use at development time. It's not something that is required when you run your app in prod or whatever. So it's really a local tool. So flagging that as optional is the best practice, because you don't want to publish that dependency transitively.
So that dependency will not only add new features, but will also trigger the right defaults for your application as well for development experience. So that's what we'll see actually. So we've restarted the application after that change, and now we'll see how the development experience goes from now.
Okay, so let's try to do this.
So,
oh my god, this is really, really big.
first thing we can demonstrate then, the simplest thing we can do when you're changing your application.
Right. So there is this this live reload thing. Everybody knows what it is? Yes, no,
yep.
sleeping.
So live reload is a spec, actually, I'd say. It's all about starting a WebSocket server and on one side, and that server is sending events to its clients whenever something has changed, and that change will that event will trigger a refresh in your browser. So here with that Chrome plugin, so there are many plugins for all browsers. That plugin actually is connecting to the server here, our localhost application, with a special WebSocket connection, and it's waiting for events. And when it's receiving an event, it'll refresh the page whenever needed. So that means that Spring DevTools, the Spring Boot DevTools is bringing that new feature. It's bringing a live reload server and feeding the browser with events whenever refresh is needed.
So we'll showcase that now. So if you look at the view for the table, you'll see that there is this deprecated tag that we add to each row. And we're going to use that to have a visual indication that the property has been deprecated. So it basically at some point it got deprecated because we decided to change the name or we changed the feature or whatever. And I can tell you already that spring.view.prefix has been deprecated because we fixed the namespace. There was a namespace issue in it. And there is no indication whatsoever in the app. So basically what I'm going to do is simply, I'm going to create some style for that.
Simplest change you can do in a web application, right? Changing a static resource in it. Right? We haven't hit refresh on our browser. So saving in the application will trigger recompilation in your IDE. And
yeah, which is easy, and admittedly you can do that without Spring Boot, except the live reload thing, but making sure that you can change static assets and have that refreshed refreshed without restarting the app. That is, if you configure boot in a certain way, you can do that. But what we want to show you is the out-of-the-box experience. You add a jar, you start your app, and that's what you get.
Yeah, but we'll try some more complex things, right?
Right.
Changing a static resource is quite easy. You can do it in some way already. But
okay, so
you can do something more.
Right. So the next thing that we want to show you is the app is pretty dumb right now because if a group hasn't changed at all, we still show it. So if you look at this one, those properties already existed in 1.2.5 and they still do in 1.3. So nothing has changed, and yet we show it. So it would be nice to have an option somewhere to say, just show me the things, the groups that have changed in some ways.
Yeah.
So to do that, we need a new option.
Yeah, so we need to change our template. We need to have some kind of checkbox to tell, right, okay, I want the whole list, or I just want the things, the groups that changed. I don't want to see everything. So for this, you can use, you can add an HTML, regular HTML checkbox that will send a new parameter in your form. So just saving in your IDE, right? It's retriggering a refresh in your browser. And but we have to continue, right? Once you've done this in your HTML, it has to be processed at the controller level to do something about it.
Right. So the name of the property is full.
Yeah.
So we need to basically, as you might expect by now, we need to have in our diff request thing, we need to have a new parameter.
Yeah. So we're not only getting the from and to versions, we're getting a new option which is saying I want to see the whole list, or I just want to see what changed.
Okay, so what we want to do, we have those groups here. And what we want to do is we want to filter them. So either this is full, then we show everything, or the group is not, there is a diff type property on each group. So add, delete, and modify, and equals. So we're going to say it's not equals. and going to collect the result.
So the list of groups you'll show is only the groups that changed, or all the groups if you check the right box. But usually it stops at this, right? When you're building a web application with Java, usually at that point you're stuck and you have to restart your server. But here we're just saving.
Oh, right. So, okay, those are gone now. So the application has been restarted as well. So if I click on Show All, then you'll see a bunch of extra endpoints. Basically, the endpoints are the ones which don't change much. So, again, just to prove that it works. And we haven't restarted ourselves, right? So how does it work? Basically, what DevTools does is creating 2 class loaders for your app. It's creating 1 class loader for the library of your project. So basically, Tomcat, Hibernate, Common, whatever. And it's loading that in 1 class loader. And then it's creating an application class loader with only basically your code, the code of the current project. It's also adding a watcher, which is basically, we already showcased that. So if you change a property or if you change an HTML template, you have your browser refreshing for you. That's because at some point there is a watcher looking for your files and figuring out one file has changed. And it's basically asking the browser to refresh. If it's a source code, what it does is basically killing the application class loader, so only the classes of your project, and recreating it and restarting the context. So the advantage of that is that you basically have a hot restart instead of a cold restart. So all the VM caches are still up to date. The jars of your project, since they have not changed, because you basically can't change the content of the jar file in your IDE, those remain there and cached. So the restart is much faster than if you do a stop and restart.
Yeah, and the difference is here, for example, in our case, the application is starting cold in under 5 seconds, I'd say, something like this.
Right.
And whenever you're triggering that fast restart of the application, you're usually under 0.5 or under 1 second for that restart, because I mean, your application is not that. The common misconception is that I mean, your application is doing a lot of things, but it's starting an application with Spring is not really slow, actually. So if you see this, you can see that your whole application has been restarted and beans created, etc. under 0.5 seconds. So
we don't have, do we have? No, we don't. Right, so this is where it restarted your app, basically. Okay, next. There is something which is also not about right in our app. If we go on the div thing.
Right now in our application we're using web jars. So we've added Maven dependencies in our POM, and those dependencies are regular Maven artifacts, but they're indeed containing static resources. So we've taken the one for jQuery, another one for Bootstrap, and that's how we're loading our static resources. We're loading those through web jars. So Boot is doing already one good thing. It's detecting this automatically, and it's serving web jars automatically. So if you add those dependencies, that's the out-of-the-box experience you get with Boot. It's you can start serving those resources from the class path. But the annoying thing with web jars is that once you've written those dependencies, and once you've created those link and script tags in your HTML, you have to change the versions whenever you want to upgrade your library, which you can do quite often. You have to change in the POM, and then you have to go through all your templates and make sure that the versions are right. And that's kind of painful, right? To maintain versions at two places at the same time. So for this, there's a library that's actually from webjars.org. It's a locator. It's looking for web jars on your class path and guessing the version for you. So adding this to your class path is doing the right thing with Boot. It's configuring the web jars locator for you and it'll help you resolve the versions for your static resources.
So because we added a dependency, we have to cold restart the app now because that jar class loader I was mentioning won't be up to date. So when you change a dependency, you have to really restart the app completely. But before we do that, let's fix. We can do that even when the application is running. It doesn't change anything. Right, so we want to change this, and for that we need to do one thing with Moustache we don't need to do with other templating engine, is to create a customizer, so let's create that quickly.
Because with other templating engines, some templating engines are relying on URL encoding facilities, and we're hooking up at that point, and we are rewriting URLs for static resources for you. That's the resource handling feature in Spring MVC. But for Mustache, we don't have that kind of endpoint, so you have to create your own customizer. That will create here we're creating a URL tag, some Mustache tag you can use yourself, and wrapping your URLs with that tag will trigger the code path we want. So we're using here the resource URL provider from Spring Framework, and that provider is helping you to rewrite the URLs of your resources.
So this is also the kind of out-of-the-box experience you get with Boot. Since we auto-configure services for you, you can basically forget about it and just inject them in your own component. So in this case, this is the view resolver, which is matching the view name, so div, to div.html in the template directory for Moustache. And that one is actually the service in Spring MVC that's going to rewrite the URI on the fly based on the version.
Yep.
So we've created a new tag called URL, and we need to use it in our template now.
So instead of using those hardcode those versions in our templates, we can do something like this. We can use that URL tag we've just created, and we can remove the versions from our URLs, and hopefully it'll do the right thing.
It won't, right? So let's see that in action. I'm still connected, yeah. Yep. Oh, so it doesn't work because we need to actually enable the resource chain to have that, actually that lookup, making sure that lookup will work. It's not, so it's basically not finding our CSS and our styling anymore.
So that's that's a way to see how you can. You see, until now we haven't done anything with properties. We haven't changed anything with the default configuration. So here you can see the actual metadata coming to life here. We are enabling the resource chain to make that happen. Maybe we should do that by default, actually.
There is an issue for that.
Yeah. So that's a big plus one.
All right, it's already back. And if we look at view sources on that stuff, then you see that the URI have been rewritten on the fly based on the version that you have. So now, basically, the bottom line is if you upgrade to a new Bootstrap or jQuery version, WebJar Locator will find the version on your project, and we will use that transparently to rewrite the URI for you, so that it always works, depending on the class path.
So change it one in your palm and forget about it.
Okay. Actuator?
Yeah, actuator.
Right.
So one of the features I like the most about Boot is the actuator one. And actuator is a bit like DevTools, I'd say. It's bringing new features and really interesting things, and at the same time auto-configuring things for you. So here, same experience. You want to add a starter.
If I type it correctly.
So the actuator one. And adding that starter will add new things, will trigger new things in your application. So we've changed the class path of our application, so we have to restart the application.
So let's see. So basically what it's going to do is it's going to expose endpoints, additional endpoints to manage your application. We're going to quickly show you some of these, and then we will show you how you can basically customize some of them for your own needs. The first one is environment, which is basically listing the actual configuration of the current project. So you can find system properties, environment properties. I'm going to quickly browse on that in case I have sensitive stuff in there. And you can see our only change, which is here. And it's actually telling where it's coming from. So if you start an app and you want to know the kind of configuration that you have on that app, you can really easily see it. And this is basically what DevTools is doing for you by default. So what it's doing, it's basically disabling caching. So by default, we will cache the templates, which means that if you change it while the application is running, you won't see the update because it's being cached for performance reasons. Obviously, when you have DevTools and you're in a development environment, that's not what you want. So it will disable that sensitive configuration for you.
But really, Actuator is about providing you with production-ready features. So endpoints that help you how to get information out of your services or about their health or what's going on with your application. So here, for example, the mappings. So all the mappings that have been declared by your application or by boot, the request mappings for your web app, they're listed here. So you can see that WebJars is mapped to the resource handling. You can see that we have our own mapping here, defined on / on the root. And there are many also many default mappings, but most of the new ones here are actually Actuator to the rescue, helping you. So we've seen environment.
Right. That's the FTXT thing.
Yeah, right. There are many others. There are many other endpoints here. So beans, all the beans defined in your application. That's actually very useful when you want to check out what's going on with your application. You can see the name of the bean, how it got created, etc. The dump is actually dumping all the state.
Thread dump of your process. No more kill -3 on a remote SSH in production anymore, right? Something more web-related is trace, where you can basically inspect the last X requests, basically inspecting request attributes, response headers, and stuff like that very easily. There is also a few other that we're going to customize here. There's the Earth endpoint, which is basically telling you if the app is alive. There is the info endpoint, which is basically giving some information about the application. Currently, it's empty because boot has no default for that. It's your application, so you basically know what kind of information you want to publish about it.
And you can also publish metrics about your application. So by default, many metrics are provided, but you can add your own. We'll probably do that later.
Right.
So you can get metrics about the number of classes, but also the counters about the number of, the status of pages you've served for your application. So here, 13 times 200 pages.
Right. So let's maybe update our info endpoint, right? Which is empty now. There is a convention for that, that if you create a key that starts with info, it's basically a map. So it will take the key and the value, and it will expose that in the JSON for you automatically.
So for example, when you're doing a continuous delivery or something like this, you definitely want to have some information about your application, so its name and probably the version you've deployed to production. So here, let's say we've deployed 0.1 snapshot. So here, automatic restart. Okay.
As always. Okay.
But it'll be better to have something meaningful here.
Yeah. So maybe make sure that the build is basically giving us the version instead of us outcoding that there. So to do that, we need to basically ask Maven to filter all stuff, and it's really easy. You just need to do that. So basically asking that file to be filtered. You may not want to enable that for every resources because typically if you have a binary file, like we probably do here, so this will not work after because it's going to try to filter it, and the binary file will be corrupted. So I wonder if that works actually. Oh yeah, it does.
Yeah,
interesting. Interesting. So IntelliJ is basically reading the Maven PAM and is doing the filtering for us. But we can also do more, and if we want to expose Git information, so if we go on the Spring.io website, and we go on /info. Yeah.
Yeah, .json, right.
Why do we need XML? You can see that we have get information about the actual version that was used to deploy that version of the site. So we want to add that to our app. So to do this, there is a plugin again. There is a Gradle counterpart if you're using Gradle that will generate a file for us, which is this one, right? So if you add that plugin and you call the revision goal, it will basically generate, because you said so, it will basically generate a git.properties at the root of the class path, and we're going to look for that. So I guess for this one, I will have to call Maven, right? Let's do that. Okay, so apparently it did some stuff here. Let's see what we have.
Good. So
Good.
we're getting the latest commit information for our application. So that's really useful. As you've seen for Spring.io, we're using, it's a good application as well, and we're using this pretty extensively to know which version is currently deployed.
And remember this, we've been demoing that for 45 minutes now already, and we haven't gone outside of the IDE a single time. So we configure stuff in the IDE, restarting or using the IDE feature, but we didn't go to the shell to run some commands, everything in one place. So we didn't have to switch to other windows or whatnot.
Yeah. So earlier we've seen the health endpoint. Maybe
Yes.
Do we want to add something here?
You want?
Yeah, why not?
Okay.
So right now we've got we've got the one health indicator, which is disk space, so the space available on Stéphane's laptop. But we can add more. We can add more, right? We can add other checks that will be triggered, and we'll get an aggregated status for our application. Okay.
So there is an API that Spring Boot exposes that you can use. And basically, if you create a bean of a certain type, we will detect that, and we will automatically improve the health endpoint with what you have defined. So let's see.
Yeah, don't do that in production.
Of course.
Automatically failing your application because you want to.
One or two times, right? So let's see. Just to show you the kind of API you get, right? Some Fluent API. I'm going to say it's up. Otherwise, I'm going to say it's down, right? Sounds like some detail. You can also add an exception if you want. Whatever.
Yep.
Okay, let's try that. Okay.
Okay, so it's down, 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 down. Oh, random, right?
And you've noticed that the status here has changed. And if you go on the trace endpoint, you'll see that the status code also will change accordingly. So it will be 503 if the application is down. So you can build command line tools that rely on that status code to whatever management system you have. You can easily, it's just an HTTP GET, right? So you can integrate that in your own infrastructure very easily. Metrics.
That's Spring.io.
Oh,
yeah,
that's
private.
What's the password again?
None of your business.
Okay, so let's see that for the sake of this application, we want to add our own metrics. It's very easy to do. I'll show you quickly how to do that. So, what do I need? Okay, so let's say that I want to record the versions that have been specified by the user to basically know what version is actually requested a lot. So to do that, again, it's the same thing. Spring Boot offers an API, and then you can basically inject a component and just start using it. In the case of metrics, it's the counter service. So I'm going to inject that, and I'll get that by default. Okay, maybe a picture. Right.
So that's actually useful. You're using this as well, I think, for start.spring.io. For start.spring.io, we have counters that give us some statistics about what developers use, like boot versions or starters they've selected when they create an application. And that's the kind of metrics you can get out of your application to get a feel of how it's used and how it goes. So here we definitely want to know which to and from versions have been selected, and that way we can know which are the most used versions when getting the diff.
So you can increment, decrement, that's for the counter, and you can also inject a gauge service, which is the thing that's recording response time, and that's a single value. So gauge is a single value. We use that to record the execution time of the last request. By default, that's what you get. Where is it? It's not by default anymore. Interesting. Yeah, here.
Okay.
So the trace endpoint took 4 milliseconds to respond the last time we executed it. And then you also have counters, which is a counter service, and you can increment and decrement the value. Right. So I think this is good, right?
Yeah. So we should. Yeah.
Let's diff something.
So let's get from 1.3 M1 to M5.
Whatever. Loading stuff. Yes.
So we're actually getting the dependencies from Maven Central, loading those with our library, checking the metadata inside the artifacts, and that's why it takes some time to load. So here we've got new metrics, right?
We do?
No?
Can't see them. Oh yeah, here we go. Thank you. So 10 times, and let's say I'm changing this for the sake of the demo, and then I should have an extra M3 somewhere. Right?
Yeah, good.
1 and 11 for M1. So by default, the actuator features are in memory with a limited size, of course, so that you don't blow you up. But you may want to record those metrics somewhere. So you may want to export them to some system and run some analysis on them. You could do that it was possible to do that in 1.2. In 1.3, we've introduced some additional features so that it's easier to configure. So what I want to show you now is how you can, it's not very consistent with what I just said, but I want to show you how you can export that to a GMX domain. So the GMX domain won't be persistent, of course, but it's for the demo's sake. You could also export that to Redis, to OpenTSDB and StatsD.
Yep, exactly.
So what do I need to do? I need to create a new bean. That needs what again? mbean exporter. Yes, so mbean exporter. Going to inject that because boot is going to provide that for me. Right. Oh, of course.
Export, yeah.
Yes. That's what I missed.
Yeah, good.
So you're basically telling to boot that metric writer, please use it to export new metrics to whatever the implementation has to do. And there is a bunch of properties you can tune to change how frequent the export is made. By default, I think it's every 5 seconds. Okay.
Let's see.
Let's see what we have here.
Okay, selecting our application.
Bam. Yes, insecure, that's fine. So if we connect, by the way, if you connect on the GMX endpoint, you also find all the actuator endpoints, so the web-based ones. Yeah. You also see them on GMX by default. So if you want to connect to a current process, you can also access to the same feature using GMX.
But we also get our custom ones.
Right, which we don't since the application has restarted, so let's refresh that stuff.
Okay.
Here we go. Bam. And just for the sake of the demo, you can also do nice things like this. So it's GMX, so it's not very interesting. But if you use whatever statistic systems, that's the kind of out-of-the-box experience you can get very quickly and very easily. All right.
So next step, we can talk about maybe caching.
Yeah, because I can see here that even though our library has some kind of internal cache, because it does not read on Maven Central every time, hopefully, we're still invoking it every time. So every time we need to do a diff, we're actually calling the library, generating a diff, so the diff object, then we actually put that in the model and render the view, even though we asked that like 2 seconds before. So one thing we could do is add some caching to our application. And again, it's a bit boring, but if you need to do that, well, there's a starter for it, right? So, which, as you might expect, is called starter cache. Very, very boring. Okay, so if we have that, basically you're all set up. And in Spring Boot 1.3, we're using RC1, by the way. GA is next week. I mean it this time. So in Spring Boot 1.3, there is many features related to cache. So basically what we'll do is look if you have a caching library on your class path and auto-configure it for you. But since caching is really something opt-in, you don't want to have cache being enabled for you without you telling explicitly so. You still need to enable it. So basically, the only thing I have to do is write enable caching here, or in a configuration class, whatever it is.
Yeah, good.
Done. So now you need to basically tag the services method that you want to cache. You have many ways to do it, but let me show you the most common way.
So here we're caching at the service level, so we don't have to reprocess and refetch resources all the time. And we're creating a cache named divs for this.
Right, and the key of the entry will be computed based on the parameters. If that's not what you want, there's plenty of options to change how the key is generated. You can plug in your own implementation. You can use a spell expression. Plenty of cases. But in this case, the key is perfect. This is really what we want to see. So let's refresh a bit, and then you can see that it's only called once now. Right. So caching is effective, and even ice on the cake. If you go on metrics, then you can see that you have a new cache. And you can see the size of the cache.
But the thing here is that we didn't add a third-party library, or we didn't configure explicitly a cache.
Oh, right. Forgot about that one. So basically, there is a fallback. So if you don't have any caching library, Spring has, for a long time now, caching support is definitely not new. Spring has a simple implementation based on concurrent hash maps. So if you don't have any caching library and you said, I want caching, that's what you're going to get. So currently, the diffs are basically located in memory.
Yeah.
So if we refresh that, a minute now, you can see that the size is 2 because we have a new diff.
Yeah. But for a real-world experience, you probably want a cache library.
Yeah.
And you probably don't want to cache independently the snapshots one, because whenever the team is pushing or building a new snapshot, then you don't want the same diff result, right?
So we basically need to have some kind of expiration. So I want to show you, which is a bit newer, I'd say, the GSR 107 support, so the JCache support in Spring. So let's try that. So for that, I basically need to add the cache API, and I need to add a GSR provider. And for the sake of this demo, we're going to use hcache 3, milestone 3. Okay, so you get the point, right? There is a caching library now in the project. So instead of creating a cache manager on top of concurrent hash maps, it's going to configure a JCache compliant cache manager for you because it found one implementation of it. If you don't want that, if you don't like that, if you wonder how you can tune things, you can always customize properties, and you can also always write your own code. So for instance, if you create a bean of type cache manager, we will find that and we will just use that. We won't try to auto-configure anything. And there's plenty of options, like you can also force the type of cache that you want, and that's the caching system that we currently support.
Yeah.
Right.
So now that we know that that cache now lives into EHCache, but we want to configure some kind of expiration policy.
Yes. So let's
for
do
our
that.
cache entries. So for this, as many things in Boot, you can customize it in many ways. So with properties or with customizers. So hooks and endpoints you can use to configure the out-of-the-box experience and to better fit your needs. So here we're just configuring the diffs region, cache region, and we're saying that we want to make those, yeah, right?
What's the expiration policy again?
Created expiry.
Thank you.
Yeah. I got my notes. So we want those entries to expire within the day or hour. Yeah.
Okay, say 1 hour.
Hour.
Okay. And we want also to enable statistics. Let me do that here. So that statistics are being exposed by the cache implementation, and we can basically read that and expose that into our own metrics endpoint. Right. We can also, just showing you quickly because it works, you can, if you don't like our own annotation, you can basically use the JCache ones, right? And we will read that just the same way.
You need to configure the name of the cache, right?
Oh, good point.
On the annotation.
That's bad. Thank you. Okay.
Good, so now we have those entries into EHCache, and we should have this expiration policy. And also we have new statistics. So we have a hit and a miss ratio for our cache. So that's a good indicator of what's going on within your application. So yeah, here, okay, 30% miss for now. And that's something that's been added because we've exported the statistics for our cache.
And if you're still awake and you wonder why the size is not exposed, that's because JCache has no compliant, there is nothing in the spec for that. So compliant caches do not have to expose the size of the cache. And they basically don't. So there's no way for us to read it.
Okay, so now we've got an application that's pretty robust. Features, actuators, caching. Mm-hmm. Well, we could move forward and add more caching for better performance, but I think we'll move to something else first.
Right. So as you can see, we have everything in one module. We don't have really a client-side app. So everything in the same module, which is obviously easier to basically build an app and have that kind of experience. So what we want to show you now is that you can also have a complex app with a separate module for the client side with an Angular-based application, for instance. That's what we're going to use, and still benefit from the exact same feature. Okay? Because one thing is, if you move your code in a separate module, then maybe you think that you're going to lose half of those features. You don't.
Yeah, because actually the rationale behind this is because nowadays applications, client applications are really rich, a lot of features. They have their own dependency management system, their own tests. They have like their applications on their own. So it doesn't really make sense, at least for us, to hide this within your web module. So having a separate module for your client application actually makes sense. And when you start using this, using that way to architect your application, then you'll see it's pretty good actually. So here, Stéphane fast forward to a new commit. So the application here has been changed. So we're still using the config diff library, the library that generates the diff data. We still have a web application, boot application, but we've changed many things in it. And there's a new module which is called client. And if you look at it, that client module has got some resources under SRC, so the CSS files, images, and your JavaScript code, because here it's an Angular 1 application. And you also have other things like Bower, because we're using Bower for dependencies here, to get dependencies from the dependencies. And we're using Angular, Bootstrap, and jQuery and other dependencies. And we're also using Node NPM to build our application, because that's what most client applications do nowadays, right?
Okay, so the client side has been moved to one module, one separate module, and the deal here is that we're going to create a web jar for it. The web module will rely on that web jar, and that web jar will be used to basically serve client-side assets.
So in the previous version of our application, we were consuming web jars as libraries, and here we will actually get libraries with Bower or in some other way, our own code, build our artifacts, and create a jar that will be added as a dependency of our web application, our web module. So we're building a web jar for us, basically, and here as a dependency.
So if you look at let's start on the server side now quickly. If you look at the dependencies, it's pretty much the same thing, except that for demo purpose, we switched to Timeleaf. So we were using Mustache previously, now we want to show you it's basically the same thing. You get the same out-of-the-box experience. We're using Timeleaf in that version. If we look at the code now, one thing that has changed is the controller. So we still have that object which validates user input. Our metrics, nothing has changed. But the controller is actually a RESTful endpoint now, and basically sending a JSON document with the content of the diff. And basically the Angular application is parsing that to generate the table on the client side.
Yeah.
So we can actually curl that, and we'll get the result of the object model.
So yeah, so instead of getting all the data within the template and rendering, we're getting a template rendering, and the Angular application is starting up, fetching the diff, the data, with an AJAX call and rendering the content.
We also have an extra web-based configuration to tell boot where to find stuff. So making sure that if we hit the root endpoint, it's going to call the index view, which is basically, this one.
Yeah. So that's our Timeleaf view.
This is pretty much what we had before now, except now it's using Timeleaf. And in our static assets, we have our favicon for now, and the CSS has been moved on the client side, obviously.
So as you can see in the template, now we're getting Angular and other dependencies, and instead of rendering on the server side our UI, we get an Angular template here in the script tag. We have the whole template that will be rendered by Angular, by our Angular application, and the app is in the client module, obviously.
So the next thing we want to show you is some setup that you might reuse for your own purpose and your own application, is how you can also integrate all that client-side stuff into the build system. And you may think that I have to install Node by myself and doing all kind of complicated thing, but actually everything is integrated right in the build. So where is the client here? Am I blind or what?
You may have to refresh, I think, the meter.
Do I?
Yeah.
Oh, yeah. Okay. So if I call install, because that's what I want to do, I want basically to build that web jars, install that in my local repo so that my server side can use it. So it's going to download Node for me. It's going to invoke dependency management and basically fetch everything that's required. And voila, my web jars have been created for me. And you can see that our client-side dependencies have been downloaded for us, and everything that's required for the client app to work. So let's start the app now.
In case you wonder, it's all documented in the client POM, the whole setting up Node, etc.
Yeah.
It's just vanilla Maven plugins.
I'm going to show you that quickly, just to show you that it's basically doing the same thing, right? Same app. You can see also that the URI has slightly changed, so that you can basically bookmark that now, which is much better. So quickly back to the client side. Right, moving that stuff away. So we have this front-end Maven plugin, which basically allows us to install Node, the versions that we want, run npm, run Bower, and basically the resource plugin has been configured to take the things that needs to end up in the jar file. So if we look at the content of the jar file, can we do that? Oh, I will have to go on the command line, really? Okay. So first I'm on the command line to show you something, right? That's it.
Yeah, the jar. So if you look into the jar, it's using a convention of a Spring Boot. So creating a layout for our resources and putting those into a public folder. And doing this, Boot will recognize that location as a static resources location, and it will serve those. So it's got several locations built in. It's got locations for resources in your static folder, but also on your class path in several locations. That's one of them. So building such a jar and putting it in your web module class path, and Boot will do the rest. We'll serve those resources for you. But yeah, in the next steps, we'll show you how to improve that client application and how you can have the same development experience with that new type of application.
Time for a break or what?
Yeah, I think we should do the break right now.
Okay. So see you in 20-25 minutes?
Yep. So just a friendly reminder, there's the Spring Buff tomorrow, 8 p.m. 7 p.m., sorry, if you want to chat with us. And we'll be also at our booth later today. Even at 5, we've got a giveaway, so don't hesitate to come and chat with us.
We also got 2 questions raised using the Devoxx app. You can use to vote and to ask questions. We had a look during the break. One question was, let me maybe...
Why is validation of version mismatch not done in version validator? So actually in our validator, we're just getting one version and checking that it looks good, right? But we could also have everything into one validator. So for example, creating a specific class with both versions we want to compare. And so validate each version and also make sure that those versions are in the right order. So we could do all the validation within the same validator. And that's just another way to do this, right?
So basically taking those 2 fields, putting that into a specific object and annotate that specific object and create then a validator that does both.
Yeah, so we're just lazy here.
You can say that.
We had also another question about how should I know to, how to do things with Spring or Spring Boot. How should I know where features are, and how should I know how to use features with Boot or regular framework, I guess?
Documentation, right? Everybody reads that.
Yeah, we've got the rev docs, we've got the getting started guides on spring.io. That's where we try to really explain the good way of doing things with Boot. Most of our getting started guides are made with Boot anyway. And we also have even a reference application, which is the spring.io website is actually a Boot application and an open source application that you can check on GitHub. It's called Sagan. So Spring.io Sagan, yeah, right. So here, that's also a real Boot application that runs in production. So if you're wondering how to do things, that's also one place you can check.
Are there any additional questions before we start? No. I got a question regarding how the link between the client side and the server side. Apparently, I think that maybe we can take 2 minutes to explain again. So the previous versions, we had everything in the web module. So the client side stuff, not much. The templating and basically the server side code. Then we split into 2 separate modules. And the client side, so this new module, is basically containing our client-side code for the application and also the dependencies that it needs. So the Angular, Bootstrap, and whatnot.
And it'll be more obvious during the next steps, because right now it's only a couple of static resources, but with the next steps you'll see we'll add many more things that really makes it an application on its own, right? So that's why we have a separate module.
So that module is actually generating a web jar, pretty much the same thing as the web jars that we used in the first version. There is a dependency between the server-side code and the client-side code here. And because it's available boot within a specific location, boot is going to serve that by default. So if we look at the content of the jar, so the client jar, you can see that everything is under the public package, and public package is being served as / by boot. Yeah. So if you go on bootstrap /less/popoverse.less, you'll get basically the resource.
So right now the next step is to show you how you can have the same development experience with that kind of application than the experience we had previously.
Right.
So the same DevTool experience, reloading, changing static resources, changing more things, and still getting the same flow of development.
So there is one downside to this new application, because since everything is happening asynchronously, you don't really know what's going on. And if we take a diff that needs to be downloaded from the repository, it may take some time, and you don't know if you clicked or not because there is no visual indication. So we're going to add that. If we want to add that, there's basically two things that we need to know to change. Something in the template, which is in our web module, which is fine, and we also want to style it. So we want to add some CSS rules to it, which is in this file, and it's in a separate module. So we need to still have the same experience of doing everything in the IDE without relying on the build system or without relying to building the web jar itself. So what we're going to do is we're going to create a development profile for our application, and when we are in that profile, we will configure boot to actually fetch those resources from the module rather than fetching them from the web jar. Right.
So it's actually showing that with really in most cases boot is doing the right thing, but if you have a specific setup just like this one, you can just plug in the behavior or the configuration you want. So here we want to tell boot that it should load resources from the file system, and they're located into the client module. And we're also telling, so here that's the static locations. We're saying boot, okay, let's load all the resources from class path static, but also from those file locations. And we're pointing to the client module. So during development, we don't have to rebuild the jar or whatever for the resources. We want to have the same experience. Just hit save and refresh the page, and the change is here.
We don't want you to hard code absolute path in your configuration because that's nasty, right? So we rely on the working directory being this module, so that // is actually resolving to this. So I want to make sure that the working directory will be the current module, and in IntelliJ IDE you have this token that you can basically set by default. So you can also configure the default to be this. In this case, you don't have to repeat that configuration over and over again. You also saw that I created a file called application-dev, dev being the name of the profile. So I need to enable that, obviously. So I'm just going to do that here.
You can do that obviously on the command line or in many ways, but IDEs nowadays, when they have Spring support, they allow you to specify what kind of profile you want to activate for your application.
The other thing also that we want to do is we want to teach DevTools to react accordingly. So if you have, DevTools by default knows where static resources are located and obviously class files are located. So it will not restart the app if you change the static assets. If you change configuration or code, it will restart the app. We're adding those additional paths. So basically, telling the file watcher to watch for those folders as well, so that if you change something, it will trigger something. And if you don't do anything, it will actually restart the app. That's the default. If it doesn't know about something, it will restart the app because that's the safest it can do. This is client-side stuff, so we don't want to restart the app. So we're actually telling it that these resources do not need to trigger a restart. And one might argue actually that that could be a default. So maybe that will change and you won't have to add that line.
Okay, so now we have all the setup we need for DevTools to behave like we want. So we're pointing to the right locations, and we've told DevTools which files should be watched and how it should behave when those files are changed. So now it's about getting back to the new feature we want to have is some kind of loading indicator when we're loading the diff during the AJAX call. So for this, we can add something into the template, the Angular template. We can add some spinning icon, some glyph icon to the template. So doing this, we have like this spinning this icon when the load state is activated in our application. And because we can do something more and to demonstrate that, okay, we changed the template, it's working like expected, but with our new configuration for DevTools, we want to make sure that when we change something into the main.css file that's now located into a separate client module, when we had some here CSS and CSS rules, we can show that here the icon is spinning right now. So without reloading or rebuilding the jar or whatever, our application is effective, and the DevTools are loading the resources from the right locations. Okay, so the main message here for that demo is back to business, right? So you took the decision to have a different build structure. You can structure your code any way you want, and basically teach boot how to read resources that you might change in the IDE. And it's pretty easy to do. So now we have an application that's more or less what we had previously, and it's got caching on the service layer. But we could do some more things, right? Because when you look at the network tab in your browser, you can see that we're downloading resources, so jQuery, Bootstrap, etc. And we're also loading the diffs as a JSON payload, and that payload is quite big right now. It's 302 kilobytes. Yeah. So there's plenty of things that you can do, and we're going to show you most of them. I think I wouldn't say all of them because I forget one. So let's work on our application to make it faster, and that's usually the things you do when you have a client-side heavy application. You want to optimize things to make it fast. So the first thing is we want that configuration diff to be lighter, because right now we are feeding everything to the client. So it wasn't really a problem when it was rendered on the server side, but right now we're sending all the data we have to the client, and we're only using some of it. So what we did is we pre-wrote a couple of things into our model. We wrote some JSON views annotations. JSON views annotations are part of the Jackson library. So whenever you're using Jackson as a serialization library, you can annotate your model and saying, okay, this particular attribute, I want to annotate JSON view, and this attribute will only be serialized when that view is active. When that view is selected, and the other ones won't be serialized. So that's a way to filter your entities, your DTOs, before serializing them. So doing this, we just have to add a JSON view annotation on the controller handler itself, and we want to say, okay, for this handler, we want to select that view. And doing this, it's taking our, so instead of 302, now we're down to 187 kilobytes. So we've filtered a lot of things from our model, and everything is still working as before, right? The application is still working, right? So, but we can do more.
what we can do is enabling compression, right? And Spring Boot 1.3 has a out-of-the-box feature for compression, and it will provide you a high-level API and deal with the details of the embedded container. So, as you might expect, we support Tomcat, Jetty, and Undertow. And we will configure, if you enable the compression feature, we will configure that for you automatically.
Yeah. Earlier, we've been using the customizer for this, but you can, for features like this, it's easier to actually try to type something into application.properties, and you don't have to check the ref docs. You can see what you have. So if you try to type a server or compression, you'll see that, okay, here we've got many things to configure SSL or...
That's also one way to know what boot can do for you, right? If you're wondering if boot allows you to do something, there is probably a few properties that allows you to customize it. So if you type in the configuration, the thing that you want to implement, basically, those metadata may give you a hint. And once you got the property, you can quickly link to the code, and you can also poke around the code to figure out what it does. Or the doc or getting starting guide, like we said.
So yeah, here we want to enable server compression, so compressing, gzipping the responses we're sending to the client. And we want to do that for specific MIME types. So application JSON, text CSS, that's fine.
I guess.
And we want to, why not tell the server we want to compress responses that are not under 2Ks, because it doesn't really make sense for us, maybe. So when doing this, saving fast restarts the application. And if you reload, I mean, you don't have to reload. We've got the, no? I know the network tab wasn't opened.
Is it? Where is it? Hello, hello?
Or maybe refresh.
Yeah, apparently, some glitch. Hello?
Okay, better. So now from 187, we're down to 14 kilobytes, gzipping. So 10x improvement, that's usually the case for gzip. And it's encoded, compressed with gzip.
So basically, you have to configure a bunch of properties, and we will adapt to that. So the next step, we can improve further. We can also tell the client to cache the object, cache the response. And we can do that pretty much safely, since these are basically a diff between two release versions, so it's pretty much easy to do, right?
Yeah.
The key is kind of obvious. It's the same thing as what we did with the server caching.
Yeah. So the next step is to add e tag on our response HTTP responses. So the client will do the right thing, caching the responses and keeping the results available. So for this, like Stéphane said, for e tags, you basically need to create some unique key for a given version of your resource. And for us, the obvious choice is to just join the two versions we're checking. Because it's a diff between two versions, we want to join the two versions. So 130 milestone 1, 130 milestone 5, or a snapshot, maybe, with the right number. And joining that will create a unique key, and that unique key can be used as an e tag.
And now what we want to show you is the response entity.
Response entity. Yeah.
Response entity API. So I'll show you quickly.
So instead of sending the object, responding with the object, the raw object, you can wrap it in with a response entity, saying I want to respond with a 200 status and an e tag that we will create, and the entity itself in the body.
So we need to change the return type, obviously, to comply to it. And we can actually ditch response body, because response entity is going to be enough hint for Spring MVC to render the result properly.
So doing this, we shouldn't have a different version of our response. We should have more information. Here, we shouldn't have, okay, let's check.
Yeah, so it's down to nothing.
Yeah, because now it's an HTTP 304. So if we look at the request itself, we see the response headers with the e tag. In our request headers, it was probably a conditional request. Under that, maybe down. If you go down.
Oh, sorry.
Yeah, with if node match. So the client now is saying, I've already got this version into my cache. If you've got if it's the same version, don't bother. Don't send it. So 3 or 4, better. And same thing for snapshots. If you look at it, we're fetching. So for snapshots, if you look at it, the e tag is actually the right thing. Yeah, here. So it's not just saying snapshots, it's got the number, the version, the revision of the snapshot.
The other thing also is that we can configure cache control. We can also tell the browser how much time it should cache that object. Again, very fluent API, so something like max age, and you say 1 day. And again, you just stay in the IDE, you go back, and basically you get the cache control thing here.
Okay, so from now, the client won't ask again and again and get 3 or 4s back from the server. When the resource is cached, it won't ask again about it.
Right, so from 300K to 14 and cached, if it has it already. But we can even do more. And for production, you may want also, if you have a big app, you may want to minify it. And you want to enable maybe a bit more aggressive caching. So we're going to show you how you can do that. So we're really going to switch to a mode where we're using the web jars. So for that, I'm going to create a different profile that we're going to call. Oh, right. We may need first to compress. Right, because it's not compressed yet.
Oh, okay. So now we've done the right thing for the actual JSON API. We're getting a response which is cached and compressed. But now you probably want to do the same thing for the actual resources that are making your client application. So for this, we are creating a gulpfile.js. So it's one of the tools you can use for your client application to build and optimize your application or whatever. So here we've defined a gulp file, and in that file we're defining a couple of tasks. One is minifying the CSS we've created, and the other one is minifying all our sources, our JavaScript sources.
So we need to add a dependency to that stuff, right? So this is how you do it.
So we're adding gulp as a dependency from our in our npm build, and so once we have gulp as a node dependency, we want to trigger that build as an additional step. So until now we had npm install, so installing all dependencies. We had bower install to install front-end dependencies. So it's just a matter of adding a new execution step in our build and just triggering gulp to build the client application and minify and whatever. We could concatenate and do many things in our application, optimize images or whatever. So doing this, we are installing gulp here. It's installed as an npm dependency. And down, yeah, it's already done. Here we can see that the gulp build was triggered and done.
Yeah, I forgot one thing though. It won't be the good content because I need to tell the web jars to actually take that instead of the source.
So in the gulp file, we told gulp to minify our files and put those into the target dist directory here. And so right now we need to tell Maven to package not the sources but our optimized sources, right? Or artifacts.
Right.
Okay. So right now we've got a WebJar built with optimized resources. But in dev mode, actually, we're still getting the regular unoptimized version, right? That's the goal. So
let's quickly show how it works in practice. Let's create another profile.
So in production, you don't want to serve the development files, obviously. You want to serve the optimized versions. But also, you want to be a bit more clever about how those resources are served and how they're versioned and cached and compressed, etc. So that's what we're building here. We're creating a new application profile production prod, and we've created a new application-prod.properties file, which will be loaded only when the prod profile is activated.
So it's empty for now, just that you actually see what we're going to change in that file will have as an impact. So let's maybe stop using the snapshot because it's going to bug me. Right, so we still have the app. If we inspect element network, right, then we can see that that's basically the same resources being fetched. And by the way, we had to download this because the browser didn't know about it since we add the ETAC thing.
But because we're getting the resources from the optimized jar right now, the app.js and main.css, you can see that if you look at the content, they're minified. So we're getting the production version of our client application. So same thing for the other JavaScript file.
So because we switch from the dev to the prod profile, this configuration is not loaded anymore. So we basically fall back to the default, which is inspecting the class path. So it will fetch basically the resources from the WebJars. So the client module basically.
One thing you want to do, because in the previous version of the application we were using WebJars locator, and in the resources URL we had the version of those resources for the libraries we were using, but not for our own JavaScript. But usually one thing you want to do with your client application is to have some kind of version string in your resource URL to put in place some more aggressive HTTP caching rules. So for this, you'd like probably to have that version string in your resource URL, but it's really hard to generate. You could do that at build time, but that's a lot of work. What we're doing right now is we're triggering a Spring Framework feature with boot. So with a boot property. So this property is enabling a content strategy. Do we have the resource chain enabled? Okay, good. Okay, so enabling this, and you can refine it and say, I only want to enable this for a given path or a set of paths. But here we've enabled this, and for all our static resources, those resources are now suffixed with an MD5 hash of the content of that file. So it means that you can be more aggressive about caching right now, because if you change the resource, the content of the resource, the name will change, the name of the file will change. So you can be you can be more aggressive and say, I want to cache those files for a day and send the cache control header for those resources. So if you get those, it's 3 or 4 right now. But if you take a look inside, you can in the request you'll see that you'll get the cache control header here.
Right.
No, max age 0.
What did I do wrong? I'm confused.
What we do? Content enabled. I don't know what we did.
Oh, crap. Oh, first demo failing. No.
So one thing I didn't explain yet is that you might wonder how those file names are changed. So actually, at runtime, the resource handling chain will look at your files, generate that MD5 hash, and whenever you're looking for a file to serve that file, it will generate that name. So in your template, if you're using a template engine like Thymeleaf or others that are using the you had the disable cache
thing again. Yeah.
Okay.
So basically what we have now is that when you hit that app, all those resources will be loaded from the browser's cache instead of calling the server. which is basically what you want, right?
Good.
And the only thing that's not cached is the live reload thing.
And if you look at the generated source for that page, for that HTML page, you'll see that it's actually Spring that is writing the right names into the HTML. So whenever you are within your template, because we're using TimeLeaf, it's writing the right name. But if you're using, if you were to use Mustache like we did in the previous version of the app, you'd have to write the same kind of helper we had to write to trigger that rewriting of the resource name.
Okay.
So now we've got an optimized application, caching for resources, static resources, and API.
What if we change some JavaScript code?
Yeah. So one thing we could do is we could definitely. Okay, you want to switch back to development?
No, otherwise it won't work, right?
Yeah. So back to development mode. Right now we want to add a new feature to our application. We'd like to have some autocomplete feature in our application, because right now you're writing stuff into the input and you have no clue of the versions you can use. So for this, we can actually update our Angular application, which is located in that app.js file. And right now we can have several. We have a map of static versions, so hard-coded versions.
Yep.
And for now, and we want to use those versions to have some kind of autocomplete feature on the client side. So.
Right. So what is it again? That one.
So for this, we can add an attribute on our input and use the type ahead library, and use those versions, those hard-coded versions we wrote earlier. And once we do that, we have the autocomplete feature. So that's the first step: getting the UI with those hard-coded versions into our Angular application.
Right. But now what we need to do is to actually expose an endpoint that gives you the version that you can use, right? You can't hard-code that to the JavaScript file anymore. So there is a service here, which is using the some Maven library to actually fetch the metadata and resolve the versions that are currently available on the repo. And it has this method that I'm going to use, which is going to just return me a bunch of strings. Okay, so let's create an endpoint.
Okay, now we want our Angular application to fetch those versions from a REST endpoint instead of getting those static in the code. So for this, Stéphane is creating a new REST endpoint.
I probably need the service first, right?
Yeah. So we're injecting the service itself that is listing all the Spring Boot versions that exist in Maven Central, and we're adding an endpoint here, Spring Boot version, and that endpoint will list all the versions. Is it missing a slash before Spring Boot? Or?
Yeah, good point.
So that endpoint Spring Boot /versions will list all the versions as a JSON payload. And that's what we'll use right now in the Angular application. Instead of relying on those static versions, we want to use the HTTP, the Angular HTTP client, and get those versions. Okay.
We probably need to tell it where to load it, right?
Yeah.
Okay, this is it.
So we're writing some code to fetch the versions list with the client. Okay, and right now we have all the versions. So if you're typing 1.3 or something like this, yeah, 1.13, 1.2, etc.
So the key point here is what we wanted to show you is the kind of developer experience you get, changing the server, changing the client in your IDE, and having that basically available out of the box without having to go in a shell and build and whatnot and restart. Okay,
Good.
there is one problem though. The 1.3 releases are gone.
Yeah.
And they are gone because if we look at the service, it's actually listing the repositories to use, and it's only checking for releases and not milestone. So the 1.3, M1, M2, RC1, etc. are gone, and we want them in that list, right? So if we want to update that service to also contact the milestone repository, we may just add one more entry and hardcode that entry in the list. But I don't want to show you that. What we want to show you is how you can create your own configuration for your own service, right? So you've seen that content assistance. There is a way, a very easy way, we're going to show you, to create your own keys and have that content assistance as well. So what do you need to do to have that? You basically need to create a POJO. Let's call that Spring Boot version properties. I think I might have that somewhere. No, that's another demo, sorry. Right. If you look at the way those remote repository value are created, you basically need a name, the URI of the repository, of course, and this is the repository mapping. So back in the Maven 1 day, where the mapping was different. Basically, it's default for everybody now, unless you're using Maven 1, and no, you don't want to do that. Okay, so let's see. I want to create a mapping between a name and a URI. I could put a URI there, but that will not change anything. Let's create an in-cache map for that. And a getter. Okay. Yep. Then we want to put all the configuration into that object so that it's self-contained and a bit more small than just listening a bunch of properties. So we're going to take that default value, and we're going to say private static final default repositories. Yeah, probably I should tell that it's a list of remote repository, right?
So here the goal is to show you, because we already did a lot of things in our application, we've optimized resources, we've done caching, etc. And usually when you start really building more features as you go, you probably want to have more flexible ways to configure your application. So instead of hard-coding things in your code, you can definitely create that kind of infrastructure to rely on this and on Boot's infrastructure and get your own properties and get the same experience.
So basically, if you haven't customized anything, and we're going to show you how you can actually customize this field. If you haven't customized it, we're going to return the default, which is what we want, right? Otherwise, we're going to loop over the things that you've configured, we create a remote repository for it, and return that. So the management of the default and the customization now sits in its own class, which is much better, obviously, than just polluting your code with that. So I need to replace that thing with, basically I need to inject that properties. And replacing that code with, it's basically pretty much the same thing, right?
Yeah.
Right. So instead of a hard-coded value, you now inject an object that's basically providing that configuration or customization for you.
And until now, that properties object is a regular POJO, and to actually declare it as a property object for Boot, you have to annotate it.
Right. So you need to add this annotation, configuration properties, and you need to give it a prefix. So it's about namespacing. If you look at the configuration, for instance, server related configuration, they start with server dot something, right? Server dot port, server dot whatever. The server part, which is the prefix, is the namespace of the configuration items you want to customize. In this case, we want to do the same thing. We want to give a prefix for those keys. Let's call that for the win versions provider or something, right? And the deal is, when you do this, if you have a key called for the win dot versions provider dot repositories dot and your configuration, Spring Boot will automatically inject those values. Wherever they come from, they could come from system properties, environment variables, it could be a command line switch, it could be located right here as well.
In the boot reference documentation, you've got a whole section explaining like there's probably 10 or 12 sources of properties,
right,
from property files on the class path, from other locations or environment variables. So you can, if you're wondering how you can inject values in those properties, then that's where you definitely want to go.
Right. So the editor is basically telling us that it can't auto-wire that because it's not a bin. It's not. Actually, there's nothing that tells it's a bin. This is not a component stereotype. This is just telling that this object needs to be bound from the environment, so basically the configuration of the app. So I'm going to quickly fix that, and there is an enable annotation for that, right? Enable configuration properties with the name of the class.
So that was the missing link. Now we're telling boot that it should check that properties class and should take care of it.
Right. The other thing is that we also have this banner telling us, hey, I haven't found the annotation processor for that thing. So let's see if we open the documentation. Generating your own metadata using the annotation processor. So you can read that at home if you want. But basically, I'm just going to blindly copy-paste what I'm being told.
Copy-pasting code from the internet?
You don't do that?
But obviously, if you don't do that, it's working. You can already put some values into your application.properties file, and it will work. Doing this will add more actually. So
it will basically generate the metadata for your keys. It's pretty much the same metadata as the one that boot is exposing. So if you go back to the app now, you get autocompletion for your keys, right? So let's say I want the release with repo.spring.io release.
I think that autocomplete feature right now is supported by both Eclipse, STS,
and NetBeans if someone is using that.
And NetBeans as well?
Yes.
Okay. And IntelliJ.
Milestone, right. So is my app running? Probably not. It was, okay, well, whatever. Okay. So if you go back in our app now, we should see something that we don't see. Why? What did I miss? Oh, good point. Thank you. Why? It's supposed to fail, right? Somewhere. What did I do wrong again? So, okay, see.
Okay, RC1, right.
So the configuration part is really important. Keep that in mind. We all need customization. We all need configuration keys. In 5 minutes, you can design your own object and having content assistance in the IDE. Oh yeah, something also I didn't mention is
documentation.
Documentation, right.
Yeah, because auto-completion is good, but it's even better if you've got a real documentation for your configuration keys. So if you do this, then
I guess, do I have auto-completion for that?
Okay.
Yes.
So right now you've got not only the type, but also the key name, etc., and also the documentation you've published for your own configuration properties. So that's a good way to build a really complete infrastructure for your own application. The same kind of experience you're getting with boot, actually.
Right. So.
So the next step, I think we can. Do you want to externalize that service or not? Yeah.
Yeah, we still have time, right?
We have some time. Yeah. Okay. So the next step is we can show you how to that versions service. Let's say we want to move it somewhere else to some other application, and we'll do this actually. We are creating another module which is called versions provider. So that's a really simple web application, boot web application, and we've only extracted that endpoint, actually. We've extracted the feature, the listing boot versions feature into a separate application.
Okay.
Otherwise, it's the same code.
Right. So, okay, maybe we need to call it right. So I should probably start it on a different port, because otherwise it will clash. So I can do that right here, which is quite interesting. So I can say go on 9090 for this particular run configuration, and I can run that. And
okay, so if we curl or HTTP that service, we can see that it's ready and it's responding with the versions. So separate application listing the versions.
Right.
So if we want to still have the same experience with our application, we have to query obviously that other application from the client instead of querying the main web application.
Right. So if we go here, it's still basically fetching the service that we've defined. So let's change that.
So for this, we've defined earlier a property that defines the service URL. So it's just a matter of changing that URL to something else here. And doing this and reloading the application or not, it was, yeah.
Oops.
No?
Oh.
Why is it?
Ah.
So if you do this, you usually get some error in your client. And you probably heard about this, or you've probably encountered this. Whenever you're querying a third-party service with another hosted on a different domain, you get an access control origin error. You're not allowed to make AJAX queries to a different domain. And for this, there are many ways to deal with this, but there's a nice way to do that with the latest versions of Spring MVC.
What am I doing?
On the provider itself.
Yeah.
So usually you can do that with JSON-P in some fashion, but the latest and greatest way to do this is to use cores. And using cores usually it requires you to set up some filter and configuration, etc. But right now it's enabled. It's an easy feature to use in Spring. You can just add the @cross-origin annotation on a controller or on an endpoint. You can even configure specific things on that annotation, so the allowed domains and the allowed methods and many other things you're usually configuring. And doing this, it's doing the right thing. So right now the endpoint is responding with the right response headers. So it's working for both pre-flight and actual requests. So the core spec is really well implemented here. You can do that with annotations, but we're also providing a specific filter, a coarse filter, if you don't want to declare this on your endpoints, but if you want to centralize this in a specific class. So yeah, you've got origins, allowed headers, etc.
What if we push that app somewhere?
Yeah, because right now it's localhost querying localhost. Maybe we can deploy that in a separate provider application and deploy that somewhere else.
Okay, so Cloud Foundry maybe?
Yeah.
That was not subtle enough. That was not subtle enough, I'm sorry. Okay. So what we want to show you is how you can integrate a push to Cloud Foundry using the build system. You can do that obviously with the command line. You can also do that with an event plugin or Gradle plugin. In this case, I have configured the plugin to deploy my app with a specific name. And there is a basic configuration here that basically tell where I should go, the organization and the space. And basically it's going to connect with, let me show you that. I hope it's the right one, yes. It's going to use those informations to connect. This is not my password, by the way, if you wonder. Don't try to decrypt it because you need the master key and I won't show it to you. So PCF instance, you see it's the reference in here, in here. So it's going to use the credential information from my local settings to publish it. So
if you actually
let's
launch
go
the build.
I could have done that in the ID, right? Is that what I want to do? Version provider.
Yeah.
Yep.
So when you do this, you're triggering the whole build, so compiling, tests, etc. And also there's a new step in our build, and that new step is getting the artifact we've built, and it's connecting to the Cloud Foundry API and provisioning and sending the application we want to run.
Right. So if I'm connecting on the admin console, right. You can see the organization here. Was it Spring.io? I already forgot. Yes, Spring.io development. Okay. So Spring.io, you see the space here. Development, and then you get basically this, which is being deployed currently. So let's curl that stuff. So it's basically telling that there's no route to it. So if I go back to my HTTP, let me maybe make that a bit bigger. HTTP, that Spring Boot versions, JSON, right?
Yeah.
Okay, so
it's not deployed yet.
Still deploying. So now is the time you dance or something like that.
So that's where, okay, it's deployed already. Okay. No? So that's actually in the same organization, different space. That's where we're actually running our own Spring.io website. That's in case you were wondering. So integrating this with your build is actually a good idea if you want to do continuous delivery, and that's how you can do it pretty efficiently actually.
All right.
So we've got the application deployed in production, listing all the versions.
Okay, I can maybe show that here as well.
Okay.
Crap.
Okay. Previously we had the RCs as well, the 1.3 RCs, but we forgot to do it.
We didn't, right? It's part of the demo. So if we go back on the service, properties, right? So we're back to that's our code, but there is nothing. No customization, but there is something called remote secret that does something.
What's this? Because what you expect is you probably have to change something in the code, rebuild the application, repush the application to Cloud Foundry, and wait for it to be ready, and then you can see the change.
But we don't want to do that, right? Okay, so let's remote push on the cloud.
So right now we are declaring a new application, and that's a remote Spring application. So it's something provided with DevTools, Spring Boot DevTools, and that's a way to interact with a remote application over an HTTP endpoint declared by DevTools, and that's a way to have the same kind of live reloading experience you get locally, but this time for a deployed application. So it's not only working for Cloud Foundry, it's working for any deployment environment, actually.
Right. So I could change the configuration thing, but I'm lazy, so I'm just going to hack the code here. So let's say areas list, either dependency, right. Okay. Change that code,
you're saving,
compile.
You can see in the logs that it's detected a change in the files. It's uploading the new classes remotely, and the application has been reloaded with the same kind of performance you get locally. I mean, it's just fast restarting the application.
So this is really useful when you have an app you're pushing to the cloud just to make sure that everything is working as expected, and you realize that you forget something. Then for small things, it's quite handy and quite powerful.
Yeah, but don't code in production. That's the only advice we can give you.
So the secret thing is what enables that actually. So if this line is commented out, those endpoints are not initialized at all. And the thing is, the remote client is actually reading the same configuration file, so it reads the same secret, basically sending the secret to the server, making sure that, yes, this is really what I want to do. This is something you would use in development, right? Development only.
Yeah. So, okay, we've showed that you can get the same experience from a regular server-side application to a more client-side oriented application to even an application deployed to the cloud. But right now, what we also want to show, we've got some time, we want to show that you've got many deployment options with boot.
Right, I forgot about that one.
Yeah. Oh.
Okay. I was done. I was like, okay, job done. Okay, there's still one we need to show you. Okay.
Because usually the questions we get when we're demonstrating boot is most often we get, I don't want to use embedded containers, or I don't want to use executable jars, or I have another specific deployment option for production. So right now we can show you that there are many ways to package your application and run it in production.
Actually, I might maybe do that because it's probably not running, right? Go back to this. And reinstalling the web jars, obviously, since I changed the client-side code.
Okay. So we're getting back to a previous state of the application to show you how you can package. So by default, we are producing a jar with an embedded container inside it, and that's what we deployed previously.
Right, and
do you want to show the original, not original thing with the jars, maybe, or not?
The what?
The fact that what's the difference between the jar and the jar.original?
Oh, right. So if we go to, not unzip, maybe missing a flag.
Because the .jar file is what we are deploying to Cloud Foundry previously. So you get all your code, but also the libraries, and also the embedded container. And some other classes.
So the actual main is a Spring Boot class that delegates to your app and basically reads those resources with a special class loader. So if you want to start the app, it's really easy. You just do this. Okay.
So when you go java-jar...
already an application somewhere.
Sorry, it started. Okay. So if you go java-jar, it's an executable jar, actually. So deploying this to whatever deployment option you want, and if you have a JVM, then that's the easiest way to get a boot application running.
Here we go. And like I said, mentioning the configuration options that you have, you can also do something like this if you want. Server.port 7070. And that's going to basically set that property. Boot is going to use it. And your app is now on 7070, as you might expect, right?
So there's a priority order between the ways you can declare your priorities and how they're handled by boot. So obviously, an environment property, an environment variable, or something you define in your execution command. On the command line, it's got a higher priority than the ones you define in your properties files.
New in 1.3 is the ability to have the jar, an executable jar actually. So let's show that. You can configure the plugin and add a flag, which is called executable. Right. So if I package that stuff now. So basically asking the Maven plugin to regenerate that auto-executable jar, you'll see that it's now executable, and you can do this. Right? It's really powerful because if you think about Unix services, you can just link etc, initd, whatever, to the jar, and it will work. Who wants to know how to migrate that application to a WAR file?
Yeah.
No? Okay. Okay, let's show that quickly. So we've been doing a jar file, but Spring Boot can easily work with WAR file as well. So the first thing you need to do is you need to change the packaging type, telling it it's a WAR file, right? That's Maven stuff. Then you need to, since you're going to deploy the WAR in an embedded in a servlet container, sorry, you may not need to. Well, you shouldn't actually package the embedded container because you may have a version clash. So that's exclusion. Group ID, Spring Framework Boot, and there is a starter for that, which is Spring Boot starter Tomcat, right? And I'm going to add it again. I'll explain in a minute why, right here with a provided scope. Boot starter Tomcat.
You don't want it to ship with your application, with your artifact, but you still want it locally because you want it to run in your development environment. Okay,
so now since it's starting as a WAR file, you need to tell the servlet container to do something when the WAR file is being deployed. And in Servlet 3.0, there is some callback interface you can use for that. And I always forget how to code it, so the easiest way is to go here. You select WAR file and generate app. So if you don't know about that stuff, it's start.spring.io. It's a website to get started with a Spring-based app. You can basically shop for dependencies, and it will create a skeleton project for you with those dependencies, and you can just start coding. It's also integrated in UID. IntelliJ and Eclipse have support for that. Right, so so it basically generates this. An empty application. Right? An empty application properties and a test, and basically the build file. If you want to use Gradle, you just choose Gradle there.
Good.
Okay, so the thing I wanted to see is this one, the servlet initializer thingy. Let's see what it looks like. All right, let's do that. Copy pasting for the win. So that's the last step to be able to create a WAR file, is to add this servlet initializer thing.
Yeah, so three things. Changing the packaging type, dealing with the dependencies, like having the servlet API imported twice, and when deploying to your container, and telling Boot how to initialize your application.
So it's basically, so basically you're telling the source of my app is this. There's plenty of other options you can use. So you have a Fluent API to customize the application before it starts. Okay, so let's go back to here, clean package something.
Yeah, so right now when we package the application, we should get a WAR instead of the jar previously.
Right, and we do. So let's unzip Tomcat somewhere. I have a Houston directory if something goes wrong. There we go. Let's make that thing executable, right? And copy our WAR file to web apps. Something like that? Yep. That's the WAR file I want to copy, not the directory. Here we go. So if you look at web apps, right?
Oh, it's only 22 bytes?
Is it? What did I do wrong?
That was the missing web XML thing.
Oh, it failed. Right.
Yeah, because we don't have a web XML.
I wonder who did that.
I know who. Yeah, the Maven plugin is looking for a web XML file.
So thank you for that. Here we go. So we're basically saying do not fail if WebXML is not present, because we don't need that actually. Okay. So where am I now? I'm confused. Okay, MVN package. Okay.
Okay.
So Tomcat, bin, CP.
Okay. So we've got a war, 25 megs.
That's better.
Yeah.
Here we go.
Okay, so the application should be running and deployed this time to specific context. So it's not really hard to get the same application running into a container. It's just a matter of a one-time setup, basically, just in your POM and in your main application class. And after that, you've got the same experience, basically.
And now I can explain why I put the Tomcat starter as provided. It's because you can do that as well.
Dash jar.
Dash jar. I'm tired. Time to stop.
Okay, so it's still an executable artifact, but it's recognized by containers as a regular var. But you still get the two kind of experience.
And you can also execute it like that if you want. So how does it work if you're wondering? We actually put the embedded container in a separate space so that the servlet container, the actual servlet container, when you deploy the WAR file into it, will not read that, because you may have conflict with servlet APIs, stuff like that. So it's copying to a separate space, and the bootloader is actually knowing about that space, so that's how it can start the embedded container for you. So you basically have plenty of options.
Yeah. And we probably have some time to show the
can try that.
VM.
Yeah. The VM thing.
So with the executable var and jar feature, with 1.3, there's you can go even further actually. So not right now.
Probably not.
So right now we're starting a VM with Ubuntu, and we'll show how it goes actually in production. So here, let's pretend we are on a production box, and yeah, so that's our little README for us. So we've got into var. We've created a var Spring Boot for the web folder, and in it we've got the executable jar. It could be the executable var version or whatever. We've also created We've also created a configuration file, and that file only contains right now just run args, just a way to show you that you can override properties. So we are redefining the port. We're not serving on 8080 but 8081. And so we've got that jar, a configuration file, and we've also created a systemd service declaration. So that systemd service declaration allows us to declare that jar as a service, systemd service, CTL.
Yeah.
So you can start the application with the systemd just like a regular service. And if you curl, I don't think it'll work like this. You have to go localhost.
Really?
You've got HTTP installed. HTTP.
Yeah, cool.
I think you did it.
Ah, yeah, I did it. Remember that. Ooh, it's time to stop.
Okay, so we've got the application running as a systemd service. And if you go system control status with the service itself, it's actually declared like a regular systemd service.
How did you name it? Spring Boot for the win or what?
Yeah, Spring Boot.
For the web.
Yeah, for the web, for the win. Okay, so you get the status of the service, it's active, you get the last lines of the logs, and that's the regular experience you get with systemd services. Good, so you can stop it and see the status. The application stopped. So that's also a nice way to deploy your application and get it running pretty smoothly. Okay,
Right.
so we've got
20 minutes for questions. Yeah.
So you can ask questions. We can discuss particular points of our presentation if you'd like. Any questions?
Anyone?
Yep.
I want to ask about DevTools. Do you publish with DevTools production, or you disable DevTools while publishing the production?
Okay, so the question is, what do you do with DevTools when you're running the application in production? Is it still enabled or not? That's the question. So when you're adding the... okay. So you can do this. But it's otherwise it's a provided dependency, so it's not a...
Right. There's plenty of options.
So there are many ways. It's actually when if you're pushing your application like we did to Cloud Foundry, the thing that enabled DevTools really was our secret property. So that master secret property, that's how we triggered DevTools. Otherwise, if you don't have that property, DevTools won't be activated. But there are many other ways as well to make sure that it won't ship at all.
That, and you can also have for instance, a dev profile where you add the dependency here. So you enable the dev profile in your IDE, and then the DevTools will be active, and you run on the command line, it won't be there. That's another option.
Yeah. Yep.
I want to ask about overhead of DevTools if they're still not disabled in production. Overhead.
Oh, overhead? Oh, the question is, does DevTools have some overhead for your code if it's bundled with your application?
There's probably a slightly overhead on startup time because of the creation of the class loader, but when your application is running, there's none.
And if it's not activated in production, then there's no overhead.
Yeah,
really.
and there is no endpoint exposed either. Yeah.
Yeah. Yeah.
If you disable DevTools, do you still have two separate class loaders?
No.
The question was, if you disable DevTools, do you still have those two class loaders? And yeah, no. It's you only have that experience when DevTools is enabled. All right.
Okay.
Okay.
Anything else you want to ask?
Yeah, maybe the Angular module was separated from the application, but I think in the web module there was the HTML extension. Is that a requirement, or can it be put in the Angular?
I got that question actually.
So the question is, should the HTML file, when we separated the application in a server module and a client module, should the HTML template be on the server side, or could it be also as well on the client side? And I guess if it's just static, if it's really static content, then you can put it on the client side and serve it as a regular resource. But in our case, it's dynamic. We want to render it with a server-side template engine. So because of that, we want to have this on the server side and have it rendered. But yeah, the bigger your client application is, and the less features and information you get. For us, basically, and even for a big application, you can only have one template, server-side template, and all the rest, all the views, etc., it's client-side. Because it's a university session and demo, we could have done better with the separation of concerns and extracted some Angular templates and put them into separate files on the client side and make it cleaner. But that's just a way to show all the code in a single place. That's it. But yeah, otherwise, the server-side template engine, it's getting less and less I'd say, traffic or importance.
I think that's it. Oh.
With DevTools, is it possible to add other dependencies to the hot reload class loader?
Yeah, go ahead.
The question was, with DevTools, can you add dependencies to the hot reload class loader?
No, but this is coming. So the feature has already been asked, and we're working on it.
Yeah. Good.
Okay. Thank you.
Thanks.